All right, well, we've reached our start time. Thank you, everybody, for your patience. Welcome to First Python Notebook. Thank you so much for signing up and coming. This is going to be a course that introduces you to the basics, the beginnings of data analysis for news using the Python computer programming language, the Jupyter Notebook, and the pandas data analysis toolkit. These are pieces of nerdy jargon that we will explain, that we will demystify, and that we will answer all of your questions about. Over the next, I hope, kind of 2 to maybe 3 hours. I don't know. Maybe we'll be quick. I don't know. We'll find out. But over the next chunk of time, we're all going to work through an example of those tools being put to use to do a story. In fact, a story I worked on myself that we'll talk more about in a bit. And we're going to go through it step by step, and along the way, learn a lot of the fundamentals that are used in all kinds of different stories, not just this one, and that hopefully can serve you in the future if you're interested in using them. And the things we're covering also are useful for a lot of things besides kind of investigative stories or whatever. The skills we'll cover could be used for analytics work, engagement work, all kinds of very important things that happen in newsrooms as well. And really, the tools weren't invented for what our example used them for either. So there's a lot of different stuff that can be done with it. And we're really going to try to cover the fundamentals is really the goal. So that's the deal. Oh, by the way, my name's Ben Welsh. I'm coming to you live from Little Tokyo in downtown Los Angeles at the corner of 2nd and Central in the office that my wife and I work from. I have been a data journalist for about, getting close to 20 years. I'm currently a visiting Los Angeles Times reporter at a project at Stanford University called Big Local News, which is a nonprofit university-based effort to try to help local newsrooms do more with data by gathering and refining big records and databases that people might not have time to do on their own. Doing that at scale so we can have it for the whole country or as much of it as possible so it can be useful to reporters in a lot of different places. And then coming up with tools that make it easier for them to do that. And so you can learn more about it if you go to biglocalnews.org. That's me. Ryan, you want to introduce yourself?
Yeah, hey all, I'm Ryan, and I am joining you from my office in Spokane, Washington, which is also in my house. But I've lived here in Spokane for quite a while and was in local news at the paper here for much of my journalism career. And that's kind of where I first started getting into Python. We used it to both, to develop the website that we use to publish our news online, but also to start doing data analysis and mapping projects and a lot of the really cool stuff that you get to work on in data journalism. I left that role to work on a project called Census Reporter, where we also use Python. It's a website that is designed to make census data easier for journalists to use. So if you want to check out censusreporter.org, that's us. You can poke around with ACS data. I think we'll get the new stuff, the new data release in there sometime in the next couple weeks, which will be fun. So yeah, thanks, Ben. So yeah, that's a little bit about where I live here in Spokane. So I've been using Python for journalism for a long time. Census Reporter is a project, a labor of love. At this point, we're all volunteers maintaining it, and my full-time role is with a program called Open News, and we exist to support people who kind of work at that intersection of journalism and technology. And we help connect them with resources they need. If you work in a smaller newsroom and you don't have access to professional development or colleagues to help double check your work, there are a lot of programs that we have, particularly designed to help people who work in journalism and tech connect with resources they need and also to connect with other people. So that's one of the reasons why getting to jump on board for a workshop like this one I think is really fun, because we got a bunch of people in here who are learning together, and maybe we'll get to know each other a little bit and hopefully have a chance to figure out why you all are really interested in picking up Python skills for journalism, because it's awesome. I'm super excited that we're going to get to learn this stuff together today.
Great. Thank you, Ryan. I really appreciate you coming to help. All right, so we're ready to begin after that prologue. So everybody needs to open their web browser and go to the URL that I've highlighted here on the screen. That is at bit.ly/FPN Lite, Lite. FPN stands for First Python Notebook, which is the name of the class. And Lite, because we're going to use a tool called Jupyter Lite. I'm going to talk about more in a minute. So everybody go to bit.ly/FPN Lite, and that should take you to a page that looks like this one. Is this what everybody sees? If you don't see this, please speak up and let us know. I'm going to try to bump up the font size on mine just to maybe make it more legible. You think that would help, Ryan?
Yeah, I think so.
And
I'll just say, if Ben is gonna be driving this Python bus, and I am gonna pitch in where I can. But one of the things that I can do is, if you're running into any trouble and you throw something into chat, then I will ping you back and can hopefully help folks work through any hurdles they're running into. So yeah, throw something in there if there's a question that you have, and I'll be happy to help out.
Okay, great. Is this getting better, Ryan? Is that legible?
Yeah, I think so.
Love it. All right. So what we have here is, believe it or not, your first Jupyter notebook. This is it. The class is going to teach you Jupyter notebooks, and the class itself is a Jupyter notebook. Oh my God, it's so meta, right? So what we have here from top to bottom is that the entire script for our class, everything we're going to learn, that we're going to work through together slowly, cell by cell or step by step as we go. All right. And this class is sort of a streamlined version of something of a longer boot camp, also called First Python Notebook, that I've been teaching for about 5 or 6 years. That usually takes about 6 hours, and it's one of these things at a conference where you get a bunch of people in a room and you just keep coding until you're done, till you drop. And also teaches a few things we won't cover today, like how to make some charts and a lot of the fundamentals of campaign finance analysis. So if you're interested in learning more after we finish today, or you really are curious about how to do campaign finance analysis, I would encourage you to, on your own time, just check out the longer version. The streamlined version here today is really intended to cover the essentials of data analysis and working with Jupyter, taking as little time as possible. And so we're going to move a little more quickly. All the code we're going to write has already been written. There'll be opportunities for you to write more and to modify it as we go, but we're going to move a little faster than we do in that longer take. All right. And so that's why I call this Fast Python Notebook. Ha, ha, ha. All right. And so let's settle all the jargon stuff before we start, right? Because there's a lot of dumb terms in computer programming that get thrown around without getting defined. And I just want to make sure we're clear about what these things are. So Python, what's Python? I'm guessing you all already know, but just to be clear, it's a computer programming language, right? It's a way for you to write instructions to tell your computer what to do, right? And to tell it how to manipulate data, tell it how to do different things. And Python can do all kinds of stuff. It can make music. It can send a rocket ship into space. It can build a website, and it can analyze data, right? Among many other things. And it's called Python because some nerds decided to call it that about 30 years ago because they really liked Monty Python. That's the reason, and there's other programming languages you may have heard of, like Node.js or Ruby or what's another one? Go, right? And these are all sort of competitors that are just trying to develop, ways to help programmers make computers do things, right? And so Python's the library we're using today. That's piece of jargon one. Number two is the Jupyter Notebook, right? The Jupyter Notebook is a browser-based interface. You're looking at it right now, which just tries to make it easier for you to write your Python code. It has a whole set of windows and boxes and buttons that just try to make it possible for you to quickly write, run, remix, but also then share the code that you write as you go, right? And it's a free and open source piece of software that was developed by a guy named Fernando Perez, that's now used by people all around the world, scientists, scholars, financial tech bros, and anyone else you could think of to kind of document and share their programming work, particularly when it comes to data analysis. It was initially designed to try to help scientists write white papers, to write scientific papers that were reproducible. So your physics paper, you have all this math in it, and it might get published in a journal, but how do you know the math actually works or is right? The notebook is intended to make it reproducible by anyone. And so that's why a lot of the interface looks like a scientific paper at times, and especially when you look at the examples. Newsrooms use it quite a bit. I've linked to some examples here that you can find on the web to read if you're interested. Cases of BuzzFeed, the BBC, ProPublica, the LA Times, where I work. Many outlets will publish on the web the notebooks that demonstrate and reproduce the data analysis that underlies their stories. And this one sort of shows their work and can help to demonstrate to the audience that they know what they're doing. And is it a really awesome form of transparency? But it's also, I think, whether you publish it or not, a lot of notebooks probably just stay private. It's a way for you to kind of have something that's reproducible and auditable and like clear, so that when you're finishing your story and bulletproofing your work, it's a lot easier to go back and see everything you did and make sure you didn't make any mistakes, right? And it's super valuable for that. Anytime I do a story that's based on analysis, I try to do a notebook. And anytime I can, I try to put it on the web. So if you're interested in seeing how other journalists use this tool, the best way to do it is click some of these links and just start looking at the notebooks that journalists have published on GitHub, which is a website where people share their code. So that's the Jupyter notebook. It's like the planet Jupiter with PY because the Y is Python, right? Though it actually does support other programming languages now beyond Python, like R, for instance. So that's the Jupyter notebook. And then I think our third big piece of jargon I just want to cover before we start is pandas. Pandas is a big, gigantic hunk of Python code that just makes it easier to do data analysis. You really should think about it as sort of like a tool belt. It's like a Python tool belt that allows you to read in data files, write out data files, sort and filter and group and create new columns, and all the stuff that you might do in a spreadsheet tool, for instance, you're able to do in computer programming code so that you can work on gigantic, large data sets, but that also so that you could automate and rerun and reproduce your work more easily, rather than, every time you redo something in Excel, of course, you have to point and click and do it, right? But in a way, it's sort of like an invisible spreadsheet that's inside your computer that you're manipulating using Python, right? I think those are all the pieces of jargon, but occasionally I will just spit one out and not realize it. And I apologize if I do that. Just feel free to interrupt and ask if you don't know what it means, right? So that's the spiel on what the jargon is, and we'll start coding here in a minute, but I just want to throw it out to the audience in case anybody has any questions about, one, the jargon, but two, just more broadly about these big tools, Python, Jupyter, or pandas, or really anything like that. Is there anything you want to know or any questions you have before we begin? Feel free to unmute and speak up. Hearing none, I will continue. Doesn't hurt my feelings, I promise. But as I get going, I can kind of get on a roll. And if I'm going off track, or you want to hear something back, or something doesn't make sense, just feel free to speak up and interrupt me. You know what I mean? I actually would like it. I think I want to interact with you guys. I want to help you understand things. I want to get you where you want to go. And so honestly, I welcome interruptions. So feel free at any time to do so. All right. Okay, so I think we can start, I guess. I think I'd like to quickly start with just a tour of the Jupyter notebook itself, which we are inside. We are actually inside it in our browser, thanks to a modified version of Jupyter called Jupyter Lite. Jupyter Lite is a sort of brand new, easy way to get one of these notebooks up and running in your browser without having to install anything on your computer. One of the most frustrating things about computer programming is getting started, just getting everything working. And Python is pretty bad about this for new people in terms of just getting it up and going. Often requires getting into your terminal, installing strange tools you may not have experience with. And it's just kind of a hassle. So a cool thing about Jupyter Lite is that it lets you just like, boom, get it going in your browser with nothing else happening. However, because it runs in your browser, it's not as powerful as it might be if it were installed in your computer, because it doesn't have access to all the gears that are inside your laptop or whatever computer you have that are sometimes necessary when you're working on large data streams. So I would say if you try out Jupyter today in Jupyter Lite and you like it and you want to do more with it or try a story, I'd recommend that you try to install the full version to do at that point to really get serious about doing the work. Because Lite is, I think, at this stage, more for experimentation. Okay. There's links right here in the full edition of First Python Notebook that can show you how to do that. I would really recommend for someone who's just getting started a tool called Jupyter Desktop, which you can find explained in that documentation. And it's a really easy kind of like executable thing you can quickly install on your computer, and it's just up and running without having to use the terminal or do anything too nerdy. So Jupyter Desktop is what I would recommend in that case. And regardless of whether you have Lite or desktop or whatever, the interface is going to look the same, right? It just will or won't be in kind of on the web, right? Where if you use desktop, it'll be on your computer and it won't be on the web, right? But once you're in here, it'll look about the same. And the interface, I think, is probably pretty self-explanatory to people who have experience with computers, which I suspect you all do. But just to kind of go over it quickly, we see here on the left is sort of a file directory. This is just as you might have in a text editor, just a space where it says, this is the folder in your computer where the environment is currently based. And here's the files that it sees there. And there's 3 files that I've prepared for today's class. There's the notebook file, which is what we'll be working in. And this is the interface where we actually write the code. And then there's 2 data files, CSV files, that we're going to read in spreadsheets in the next few minutes to do our analysis that I've prepared. I'll tell you more about those in a minute, but that's what we're looking at. And here, as you create more notebooks or files or folders, they'll show up here. And, you can make a new folder. You can import files. You can rename files. All the sort of things you might expect from a file explorer elsewhere on your computer are there. That's on the left. You're able to hide that by clicking the folder button, which might be nice if you have a smaller screen. I tend to leave mine open. I don't know why, just my habit. There's also a table of contents option and an outline option there, but we won't use those in class. Those are a little more, they're not essential to what we're covering today. On the top bar is, of course, like any program, pull down menus that have a variety of actions available to you. We won't necessarily need to use these today, but it's the sort of things you might imagine, like saving your notebook is a key one. The ability to copy and paste your code in what are called cells, which we'll get to in a minute, is very useful. And then the ability to run maybe the whole notebook in one big swoop, which we'll try later, or other things, restart it if it's having trouble. That kind of thing is up there. Then finally, there's sort of the main stage, which is where your notebook is based here on the right in the middle. And that's where you write your code and your annotations. It has a key toolbar at the top that has a number of actions that we're going to get to in a second that allow you to create new cells, put stuff in them, run them, that kind of thing. Did I miss anything there, Ryan?
Excuse me.
I feel like I'm learning stuff as we go. Oh,
okay.
Here we got a question maybe.
Hi. Is it okay to ask a very quick question?
Of course.
I tried a save as on my computer, and I'm wondering if this is bothering for you. If so, I'll delete the my saved file as soon as possible.
No, please feel free to save it. You know what I mean? This notebook is free and public for anyone who wants it. It's actually available on GitHub if you know where to look. You know what I mean? And once this class is over, I plan to share it on social media so as many people as possible can see it. The whole point of putting it together is to share it. So feel free.
Thank you. Thank you.
Mm-hmm. Thank you for coming. Okay. So that's the basic tour. We'll get into more details as we go, right? And the key thing in your notebook space are the cells, right? The cells are little boxes, little chunks where you can type in your Python code and then run it piece by piece as you kind of build up your notebook and build up your analysis. And right here, I've written kind of the first cell of our notebook, and it has some really, really intense computer programming going on here, right? It has math, all right? And the math is basically just 2 plus 2, which, believe it or not, is Python code. Python can do all kinds of things, including math, right? And so just by typing in 2 plus 2 and writing a little Python, I've written my first code cell. I know it's a code cell because up here at the top, I select it with my mouse, and it's now blue on the left, right? That means that this cell has been selected for use by the user, and you type in whatever you want to do. We'll do one in a second. And then if you hit the play button up on the toolbar, do you guys see that? The play button, it's a little triangle. Or if you hit Shift Enter as a hotkey, that cell will be executed, right? And you can see that the blue bar moved down one because it's executed the cell and moved down to the next cell. And then the result of what is in the cell has been printed as an output just below it. So 2 plus 2 equals 4, right? And if I were to edit that cell, if I were to say 2 plus 2, 2 plus 3, and hit play again, it now outputs 5, right? So I'm able to write the cell and run it, edit it, and rerun it, right? And that's just the very basics of the notebook. I've left an empty cell just below that. And now my challenge to all of you is just to click into that cell and write a math problem. Really, any problem you want. Pick your favorite numbers. I don't know. Just try something. All right. Ryan, what's your favorite number? What's the best number, Ryan?
2015, because that's the last time the Royals won the World Series.
That definitely is it. And how many times have the Royals won the World Series?
They have won it twice.
So I'm going to take it times 2, right? So if I want to do 2015, and then multiplication in Python is a star or an asterisk. So if I just type 2015 times 2 and then hit play, I get the result, which is the next time the Royals will win the World Series in the year 4030.
Yeah, that's actually accurate.
Does anyone else have a math problem they'd like to share? No, okay. So that's like the very simple basics. You know, I like the hotkeys. You may see me hitting Shift Enter or not clicking play. I just kind of got in the habit of doing that. I'll go there. Yeah. So the code cells aren't the only kind of cell. You may have noticed I have all this text through here that is the actual course materials. If I double click on the next cell, you'll see it turns into a box with just text in it. But if you look carefully up at the toolbar, you see it doesn't say code. It says Markdown, right? Markdown is a simplified version of HTML. And so by telling Jupyter that this is not a code cell, this is a Markdown cell, and writing in here what I want to write, when I run it, it prints it out like text. And so stacking your code and text is the way that people kind of annotate their code and explain it and create their little scientific paper, right? And mixing those two cell types is really a big part of the art. If we go back up to my like larger box here about Jupyter with an image and hyperlinks and just click on it, you can see that it opens. It's a Markdown cell, and this is how Markdown does image tags, and this is how Markdown does hyperlinks, right? And so I just went here before our class and typed all this out, hit play, and there it is, right? All right. Now, not every cell runs smoothly. In fact, you'll probably before too long start having errors. I know I have them every day, all day. And when a piece of, the computer only does what you tell it to, exactly what you tell it to. And oftentimes we don't give exactly the right instructions. We make a typo. We don't do something exactly right. And the computer will kind of puke out a complaint at you called an error message or a traceback. And so you can see here in this next cell, I've intentionally created an error where I've done 2 plus 2 plus and nothing else after my cell. And when I run it, I get this red box, right? And the red box is the computer. It's scary at first. You're like, what's going on? What's wrong? It's also like really kind of hard to read and odd. And it's just because Python hasn't done a very good job of making its error messages legible. But if you really stop and kind of listen to what it's trying to tell you, you can usually figure it out. And here it's a pretty simple error. It's saying there's a syntax error, which in programming means the code that you've written for me just doesn't really work. It has like something kind of fundamentally wrong about how you put the code together. And the case here is Python doesn't know what to add, right? Because there's nothing after the second plus operator. It's just saying, I don't know how to do this math. There's no number on the other side of plus. And so solving that is really just as simple as sort of spotting the error, figuring out what you kind of typed wrong, correcting it, and running your cell again. And you can see here just below that, I've done that with 2 plus 2 plus 2, where now if I hit play on that one, it'll work. I should probably clear my outputs so that we don't have spoilers as we go down here, right? So if I had 2 plus 2 plus 2, now it's 6, right? 2 plus 2 was right there. Okay. Now, those cells, when you do it like this, they kind of just exist independently. You write some code, that's the input, you run play, it spits the output. But putting together an analysis and building something as you go down the notebook requires carrying over pieces of information between your cells so that once something is sort of defined, it's reusable as you go. Like, for instance, your data table, right? Very simple example of that is just, programming variables. So, that's really just like saving a piece of information in like a name so that you can reuse it over and over again as you go. And the Jupyter cells, once you define something in one cell, it's reusable in another cell, right? So here's a very simple example where I've decided to name my variable number. I could have named it anything. I could have named it Ryan. I could have, named it Ben, but no, I decided to name it number because that's what I intended to define it as. So, right, the variable that I've called number, I'm using the assignment variable, the equal sign, to set to the number 2. So if I click on this cell, which I've written and hit play, you see, we know that it's run because this little box fills in, but you'll notice there's no output, right? Unlike 2 + 2, there's nothing under the cell. That's because rather than just spit out its result into the notebook, we've said, hey, take the result and save it into this variable, right? And that variable is now reusable in subsequent cells. So in the next cell, I've done number plus 3. So instead of 2 + 3, I'm doing number plus 3, right? And if I play that cell, it spits out the output, 5, right? Because number was defined as 2, it's reused here in the simple math, and then I get the output. Now, if I were to redefine number, instead of 2, I want number to be 3, and put that in this cell, and then run the same thing again, the result is 6, right? So number plus 3 here was 5, number plus 3 here was 6, and that's because I changed what number means, right? I redefined number as something else. And your variables can definitely change as you move down the page. That's a common technique. You got to be careful about it, though, because you might lose track of what it is as you go. Or you might run your cells out of order, which could introduce some mismatches between your expectations and what code has actually been run, right? So you got to be careful about that, but that's just part of it, comes with the territory. All right. So before we move on into pandas, I just want to challenge everybody again to try to come up with another math problem, maybe defining a variable as they go. So let's see. I'm going to do the last time the Chicago Cubs won the World Series. So I'm going to say Cubs win. Notice I have an underscore. Your variables can have underscores. It's going to equal 2016, right? That's the last time the Cubs won the World Series. Now, if I hit play, now that just saved, it didn't go anywhere. One thing I haven't covered is how you can add new cells. So let's say I want to use Cubs win for math and a cell just below this. If I click on the cell and then I hit this plus button in the toolbar, it's going to add a new blank cell, which is a really common technique. You just want to have that and save it. Okay, so Cubs win is 2016. I'm going to do Royals win is 2015. I'm going to run that with Shift Enter. I'm going to add another cell. And then I'm going to ask a really clear question that is science. Science. Is Cubs win greater than Royals win? Right? Are the Cubs better than the Royals? Let's get the answer mathematically. Right? Greater than's another operator. There's a less than. And the answer is, of course, true. The Cubs are better than the Royals. Did you know that, Ryan?
I'm sad to admit that I did know that, Ben.
All right. Was everybody able to experiment with their cells, maybe make a variable, do a little math? Any errors encountered? I always love hearing about errors. I collect them like a zoologist. Okay, you guys are sharp. You're sharp, or you're bored with me. I'm gonna keep rolling. We're gonna get into the exciting stuff soon. Our next section is introducing pandas. I've already explained it. Pandas is really a fancy spreadsheet that you run in Python that can do all kinds of stuff, right? And we're going to get into what that stuff is pretty quick. But to use it, you have to import it. Pandas isn't available. The plus sign, the minus sign, those are just there. Python has them. They're in the standard library. When you install Python, you got that stuff. But a lot of people use Python to create other Python tools, which they then give away to the world for free, but you have to install them before you can use them, right? And they're in something called the Python Package Index, which you can read more about if you link. And one that's used by lots and lots of people is pandas. And once you have pandas installed, which Jupyter Lite, gratefully, we're grateful for, does for us, right? You need to import it. So anytime there's a Python library you want to bring into your notebook for use, you have to use this little import command that's built in, and then the name of the package. And if all these packages have websites or they're on GitHub, and you can usually see there in some documentation or goof around a little bit and figure out what the right thing to import is. In the case of pandas, it's import pandas. So I want everybody to click on this cell and hit play. Boom, we can see nothing happened and the number filled in here on the left. That's good news. That means our browser is able to bring in pandas. It's available. It's already installed. If you try to import a package that isn't installed on your computer, you're going to get an import error, which is really common. It just means you got to get the tool installed, which usually means using something called pip or other Python tools that are capable of downloading and putting extra Python packages on your computer. Right.
Hey, Ben, what does it mean when a little asterisk shows up inside the cell number next to the cell I'm running?
Great question. So when I hit play here, keep your eye where it says 17. And you'll see it went to 18. Okay, well, between 17 and 18, there's often a little asterisk that you'll see pop in. And that means the computer is working, right? So sometimes your computer code takes more than a second to like finish. And while you're waiting for the computer to finish, inside that box, you're going to see an asterisk. In the upper right-hand corner where it says Python up here, and there's this little empty circle, that will also fill in. And it just means your computer's working, right? And since pandas is a lot of code, it's a big library, sometimes it can take a while to import it, especially if you're running it in a lightweight tool like Jupyter Lite. So don't stress, just be patient, right? And let it finish. Those are moments of drama, though. Will it work? You know, the tension rises. Okay, so that we have pandas imported, and now just to demonstrate, like you don't have to do this, I'll make another cell, and now pandas, the variable, if I type pandas, do a dot, which we'll learn more about later, and hit tab, we'll see this autocomplete opens, and this is Jupyter showing us the hundreds of utilities on the pandas tool belt. So the pandas tool belt can do lots and lots of different things, and they're all available via this pandas variable that we're going to use later to sort of take them off the tool belt and put them to use, right? I want to delete this cell. Like one handy way to delete it is just to cut it. So I'll click right there and I'll hit the scissors. Boom, the cell's gone, right? You can also hit X on your hotkeys and that will delete the cell as well after.
Hey, Ben, I think Catherine maybe has a question.
Yeah, let's hear it.
No, I'm okay.
Oh,
I'm
awesome.
just hearing
All right.
you. Okay, thank you.
Love it. So now this next cell, I'm going to import pandas, but I'm going to do it a different way. If you've ever seen pandas code before, you've probably noticed that there's the variable PD is all over the place. PD this and PD dot that, not pandas. And all that is a shortcut, right? So the people who invented pandas, even though they decided to call it pandas, they felt it was too long and it was just a hassle to have to type pandas all the time. They wanted to make their code more compact and be able to write it faster. And so they introduced kind of a really a style convention, you know, which is abbreviating pandas as PD. So when you import a library in Python, you have to have the full name of it here. But if you put as and then a new variable after as, you can redefine it as an alias or something shorter. And so in almost all of Pandas documentation and in examples you'll find in Google searches, you're going to see PD used, right? And that's because they've done an import in this style. You're technically not required to do that. It's entirely optional. It's just sort of a matter of art, right? And we're going to do that in this class just to kind of fit in, you know, peer pressure, okay? And so to do that, I'm going to click on this cell and I'm going to hit play. And you're going to need to do that too, because this PD variable is going to be really important to us as we go down the page, because we're going to be using it again and again to do things. So go ahead and run that cell and hit play. Once we've done that, we have our tool belt and we're ready to start working with math and doing stuff with pandas. Before we get into the data from the story, like the real world stuff, I want to use a simplified data set just to demonstrate some of the principles of pandas in a way that's really easy to keep track of and kind of just introduces you to some of its functionality, right? Before we get into something more complicated. And that's just going to be calculating basic descriptive statistics. One thing pandas is really good at is taking a list of numbers and doing stuff with them, not just adding them or subtracting them, but calculating all the statistics that we use to do stories, like mean and median or min and max or all those kinds of things. And you're able to do that in Python. Python can do those stats, but you often have to write quite a bit of code to do it, or you have to be kind of good at Python to figure it out. You have to write the math formula, right? Well, Pandas has all the math formulas already worked out for you, so you don't even have to know them. And it could do them with a very small amount of code. And it can do it really quickly over gigantic data sets, which is why people like it, right? So a simple example just to start with is here, this next cell, where I've created a sort of example data set. It is the even numbers between 0 and 10, right? And so here I have a variable. I've called it my list, just because I couldn't think up a more creative name, right? We'll say my list, right? And we're going to say equals. So the variable will be equal to, and here's something we haven't seen yet. This is just a list. So Python has a data type called a list, which is kind of like a column in a spreadsheet, if you think about it, right? That has all of the values between two flat brackets, and everything in that flat bracket is in a list that you can then run sort of special operations against. And so we're going to start with this very simple list that I've pre-written, 2, 4, 6, and 8. Hit play. My list has now been saved to equal that. If I were to add a new cell and I were to just run my list, you would see that there in the output, it spits out the result, right? So we took our list, we saved it as the variable. If I just run the variable in another cell, it spits it out. It's there, right? For instance, if I were to change this to 7, rerun it again, 2, 4, 6, 7, right? I think you guys are getting the hang of it, I bet. Okay, great. So that's the standard Python list. That's the vanilla list. We want to upgrade this list to be a pandas list so we can take advantage of all pandas' great statistical functions. Pandas' term for a list is a series. And again, that's just a term of art that the pandas developers came up with for a list of things, right? They couldn't call it a list because Python already calls it a list. So they had to call it something else. They decided to call it a series, okay? And you can see here in this next cell that I begin with the PD variable, which is pandas, right? A period, which is how we begin to access the many different tools on the pandas tool belt, and then the name of the tool I want. The name of the tool I want is capital S series. I know this because it's in the pandas documentation and I read about it elsewhere. There's hundreds of other things in pandas I know nothing about, right? We only need to know 5 or 10 of these pandas terms to like do stuff in this class, but you will kind of gradually have to learn them, right? And so here I'm saying pandas, I want you to make a new series. I want to define a series, capital S. And then there's an open parenthesis and a closed parenthesis, which is a common computer programming way of calling a function or of kickstarting a process, which requires an input, something to be, submitted to be created. And so here I'm saying, pandas, I want you to make a new series, and the input into that series is my list variable of 2, 4, 6, and 8. And the result of that, I'd like you to name my series, right? So we're going to make a new variable based on the list that will be the series. And so I'm going to run that cell. Just again to demonstrate what's going on, you don't have to do this. I'm going to make another cell and spit it out. And we can see here, yes, it no longer prints a little list. It now has this sort of other like ugly thing, which is pandas sort of representation of what a series is, right? A series is a list of things. There they are, 2, 4, 6, and 8. And then pandas has sort of what they call an index, or, just like an incrementer on the left that counts the rows. So row 0, computers like to start with 0 when they count. No one's ever explained that to me. The first row 0 is 2. The second row 1 is 4, et cetera, right? So we now have a series. And now that our list is a series, it has the superpowers of pandas, right? So in the same way that we could do PD dot and access all kinds of stuff, my series dot, if I hit tab, I get the autocomplete, right? We can see your series has dozens and dozens of special things it can do, right? And again, you only probably ever need to learn a couple of these, but they are just different math operations, different stuff. And we're going to go through a few as we continue. And some really valuable ones are the ones that do descriptive statistics. So in that long list were things that calculate, say, the sum, right? So my series dot sum, if I hit play, there's the open parenthesis, closed parenthesis, which is again sort of calling something, issuing a command for the computer to do something for you. But there's no input in this case. And the input isn't needed because the data is already in the variable, right? So Python doesn't need you to give it the list to do the sum. It already has it in the variable. And so just by naming your series and running .sum, open paren, close paren, boom, it spits out the answer 20, right? And if we go do the math ourselves, 2 + 4 is 6, + 6 is 12, + 8 is 20, that checks out, right? So we've been able to total that right there. You can also do the maximum value. My series.max, right, is 8. That's the highest value. My series.min is, of course, 2. Mean is the average, right? You can really quickly calculate the average. The median, which is not fun to calculate on your own, right? You can just boom right there, get the median is also 5. The unfortunately named STD function does the standard deviation. And then there's one sort of mother of all functions called describe that will just take your series and it'll run a whole set of descriptive statistics for you automatically, telling you how many items there are on the list for the average, standard deviation, min, max. And all you statistical folks on this call know that the 50th percentile is, of course, the median, right? Right there in the middle. Get a couple other cuts too. And this is pretty simple math, of course, or whatever, but it's important to keep in mind the principle that if my list contained one number or if my list contained 1 million numbers, the computer programming code that you wrote would be exactly the same, right? You're able to run some of these stats and without any more code than you just saw right here in this notebook. And it's pretty easy, right? And just to demonstrate a little bit of the notebook and how that's possible, if I were to go in here and change this to the odd numbers, 1, 3, 5, and 7, and then I were just to go quickly and just run all my cells, boom, 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 we can see that all of the outputs have modified and changed to reflect that we're now running the same statistics on a different series of odd numbers, right?
So, Ben, I know that you're using this as an opportunity just to kind of introduce some of what pandas can do. To me, it looks like describe and median and some of these functions that you're walking us through are pretty useful in exploring a data set that you don't know anything about, coming into a project where you don't know what the outcome is going to be. And it seems like the notebook, I'm putting this on a T for you, Ben. Do you use notebooks to just kind of explore things before you know what you're doing, like we do in our class today?
Yeah, that's usually how it starts for me in a journalism project. Is I have a data set that, I've been seeking out that I want, you know what I mean? But I don't know exactly what's in it. And I'm often using the notebook to kind of ask questions of the data. How many rows are there in this darn thing? What are all the columns? We'll get to that in a bit. What's the distribution of the values, and just exploring the data is definitely where I think almost all data journalism projects start, unless you really have already mastered the data set and fully understand everything about it, which is for me is never. That's usually where it begins. And my process, from like beginning exploration to a published story usually involves like at least 3 drafts of the notebook. With the first one being full of all kinds of doodles and questions and like mess as I try to figure out what's in there, ultimately honing that down to the findings that I want to like share with the audience. And the final version, I usually limit to just sort of the findings and the shortest line from the data to the end, just to sort of spare the reader, you know what I mean, of all my missteps and sort of things. So that is to say, when you first begin, it is totally normal for your notebook to be a mess. You know what I mean? As you kind of sort out what the heck you're doing. But I really would encourage you to go back to it and revise it and work over it. And to be honest with you, that's really the power of this, is that you're able to like incrementally strengthen your analysis and your process by returning to it, editing it, and going back over and over it again. Where if you're just always exploring or you're goofing around in a spreadsheet, it can be tough to like, put one foot in front of the other and really get stronger and stronger as you go.
I'll just throw in one of the things that I think is so cool about notebooks like this is you're documenting that exploration as you go. Like I find it so annoying to like, all right, I got to take time from the thing that I'm working on to go like write my notes. But like, this is just kind of doing that automatically as you go. You're kind of keeping notes that you can throw markdown cell in there to kind of to give yourself some text notes, but you're seeing the process that you use to get where you ended up, and like being able to reproduce your process is super helpful when it comes time to double check your work, like all those things. So working in a notebook, you're just kind of getting all those notes for free in a way that you don't necessarily have if you're just writing code in another system.
Totally. That's why I love it. So that's how series works, which you can also think of as columns, and some of the basic stats. Do we have any questions about that before we move on to tables and some real data?
Excuse me. Speaking about averages, how can I get the mode of the series?
How can you get the mode? That's a great question. I didn't cover that, and it's not in the describe function. So it's just, something they maybe overlooked or didn't include for some reason when they created this. Just to kind of demonstrate the process, I have questions like that all the time. How do I get pandas to do this? How do I get pandas to do that? You know what I mean? You're going to be in that position all the time when you're doing that. And, the number one way, it seems like simplistic and not to like be whatever about it, overly simplistic, but Googling it is like the way to almost always do it. So like, honestly, like figuring out how to write the Google searches that get you where you want to go with pandas is part of it. And it's not that hard. You just kind of have to struggle to get what you're looking for. So like, to me, it would be like, get mode of pandas column. See right there, get mode of pandas column. It's like, one already there. And you can see the first result is actually the documentation for pandas itself, right? Which is not always the easiest to read, but can be pretty helpful. And we can see here that it's saying that there's a dot mode, right? Here it's saying the mode is on the data frame, which we haven't got to yet, but I bet you it's going to work, right? And so if I go back here, I add another cell. I'm going to do my_series.mode. I'm experimenting. I'm not even sure, right? I hit play. That doesn't look like it's it, does it? 1357. No,
Yes,
that didn't work.
that's exactly what I tried. I Googled it and tried that method, and I get that same result.
Yeah. So like, I honestly don't know the answer to this off my head. So let's struggle through it together. Another website you'll commonly run into is Stack Overflow, which is where people go with their questions like this, and then other users like help them. And so this guy is saying there's a data frame.mode. This person is, and that's not what we want. We tried that, right? This person is saying, I import a different library to calculate the mode. I'm using a different Python thing, right? We actually don't have a mode in this data set though, right? Because there's no duplicate numbers, right? Because they're all there equally. Let's add a number that's there more than once, right? The mode is the most common number in the data set in terms of frequency for folks who may not know. So I'm going to add the number 1 in there like a bunch of times, right?
Yes, you're right. Yeah, you're right.
And then I update the series. So I updated my list and I reran the series. And then I go down, and you can often do this in your notebook. Just run the cells you're most interested in. Now that worked, right? Once we had introduced that there was more than, there wasn't a tie, right? We kind of created a winner of the mode contest. Then the number 1 came up first. So now, for instance, if I go and change these all to 2s, right? I rerun my list. I have to rerun my series to update the series, right? And then I rerun the mode. Now it's 2, right?
Thank you.
Make
I
sense?
understand. Yes. I tried the same thing. No, thank you.
Excellent. And that process you just saw.
So the method is kind enough to show all the tie items, not arbitrary one, but if there's any ties, the method shows all the ties.
It does appear to do that. I didn't know that. I just learned that, but that does seem to be true. And like that process that you just saw me stumble through, how do I do this thing? Google it. I think I know what this is telling me, but I really don't, right? I don't want to import another library. That seems dumb. What? And then ultimately it came back to me thinking like, my data set doesn't really have a mode, right? And then I've got to tweak something, only rerun 2 or 3 cells, and then I get it. Like that cycle of like, I have a question, I'm confused, I experiment, I find something I didn't expect, a bug or thing, and then I update just the cells I need to. That is the cycle. That's it right there, guys. It was like a really simple like example of it. So thank you for sharing it. But you're going to be doing that all the time as you do this work, to solve different types of problems.
Thank you. Well, I can see the good point of the reproducible notebook. Thanks.
Exactly. Because if you were just writing Python code in a text file, you'd have to rerun all the code from the start. But here we were able to just in a targeted way rerun just the cells we needed to, right? Which sometimes cells take a long time to run. That could be really useful to not have to rerun at all. Yeah. Okay, great. Thank you so much. So we're going to move into our next section, which we're going to talk about data frames. And just like series is sort of like the pandas brand name for a list, data frame is just like the brand name for a table or a spreadsheet, right? It actually isn't invented by pandas. Data frame is like a more general computer programming term. I don't actually know the origin. If anybody knows the origin, I would love to hear it. But all it really is it's just another name for a spreadsheet, except it's one that computer programming languages can muck around with, right? So if you ever get introduced to the R programming language, which is used for a lot of statistics, they call tables data frames too, right? And I think there's probably other libraries that call them other things, and it's just what people have decided to call a table. And what is, of course, a table? It's a collection of columns and rows. Instead of just like one series or list, it's a bunch of them, side by side. And then they tend to have a name at the top that tells you what is in that column, which is often called the header, right? And so we're going to use two sets of data in this class, and we're going to get into the real world stuff here. So we're using two manicured, kind of cleaned up data sets from this story that I worked on that published in 2018, which is about the Robinson R-44 helicopter. It's an investigation I did with Kim Christensen at the LA Times. And our finding, based on the data analysis, was that the R-44, the world's best-selling civilian helicopter, is actually also has the highest accident rate of any helicopter. So, is that the fault of the pilots? Is that the fault of the helicopter? The story gets into all that, right? But the statistics are, and it's disputed. The statistics are undisputed. The Robinson helicopter has the highest accident rate. And the data that is in this notebook that we're going to go through is how I established that so that we could report it in the story, right? And the way I did that, I calculated the rate is on the one hand, I had the database of all helicopter accidents, which came from the National Transportation Safety Board. We can see that right here in the left in the finder. That's our NTSB accidents, National Transportation Safety Board accidents. If I double click on it over there on the left, look at that. In a new tab here, Jupyter opens the spreadsheet. You can't really edit it, but you could preview it. And we see here in this spreadsheet, this is the data that I've kind of put together for class. And one thing I always ask myself when I'm inspecting data is, what is a row? What does a row equal? And here, if we look at this, we can see that each row is a helicopter accident, right? And I've put into, and this is the unique ID of the event. And then we have here the make and model of the helicopter from the NTSB, the year of the accident, the date of the accident, the location, how many people died. And then we have here this LA Times make and LA Times model, which we'll get to, which is the standardized cleaned up version of the government data, which had a lot of variations and noise in it. And we'll get to it as we go, right? And so this is the columns in the data. And so in Pandas terminology, this is a data frame, and each column is a series, right? And so that's data set 1, which has all the helicopter accidents. Data set 2 is from the Federal Aviation Administration, and it's survey data that tells us how many total flight hours each of the major helicopter models had over the period of time that we're studying. And this is data that is actually derived from a long and winding FOIA request that I had with the agency we won't get into, that I've tidied and cleaned up here to try to make this class a little more like a cooking show and to move along a little quicker. But basically, we can see here that each row is an LA Times make and model, a cleaned up helicopter, right? There's the Robinson R-44 right there in row 10. And on the right is the total number of hours based on survey data that it's estimated that helicopter was in the air, that pilots were flying that helicopter during the period. And if you think about it, you're trying to adjust, right, the accidents versus how often then they're in the air to try to make fair comparisons for different helicopters. And this is one technique for doing that. And so as we go, we're going to combine these two data sets and calculate that rate using data frames, right? Any questions about the data sets before we get into how to use them with pandas? No? All right, let's keep going. So in our next cell, we have here our friend PD again. PD, just as a reminder, is the shortcut for pandas. So PD dot is what gives us access to all of pandas' many, many, many tools. One of those tools that you'll use a lot is read_CSV. This will read in a CSV file. A CSV file is a file of comma separated values. It's a spreadsheet, right? It's, you've all seen them, right? And so a CSV file, we just opened them and looked at them. A CSV file can be parsed and read in by pandas as a data frame using the read CSV function. Again, the parenthesis to sort of call it. And then it wants you to give the name or path to the file inside of quotes so it knows where to find it. That's the input in this case. So I do pandas.read_CSV, and I've typed in the name of the file, which matches what's in our Finder over here, and I hit play. And boom, you can see right there below it, it spits out the result of that function. And the result is a table that looks a little bit like that spreadsheet we were just looking at, right? This is the sort of pandas representation of the data frame. The notebook puts it out in a way that we can kind of scan it, look around at it. And this is what's nice about the notebook is you can inspect your things as you move along to kind of look at them without having to rerun all your code, And so we can see here, there's the table as we saw in the preview, but now it's in Python. It's been read in by pandas, but it's just being spit out, so we can't reuse it. In our next cell, we're going to save it so that we can use it in subsequent cells and start to do analysis. And it's the same thing as we did with those numbers earlier on, exact same concept. We name a variable. We can name it whatever we want. I'm doing accident_list, right? Then equal to define it. And that exact same code from above. So the same code from up here with read CSV is down here. It's now being saved to a variable. If I run play, nothing happens. The number shows up. That means the data frame has been saved in the same way that we saved our series, right? And in the same way that we ran statistics on our series, we can do all sorts of things with our data frame, right? So again, just to make a new cell, if I type in accident_list, hit dot, and then tab, we get the preview. And there are the many, 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 many things a data frame can do, right? You'll never learn most of them. It's fine. But there's a few that you're going to use all the time. And one is called head. So your data frame variable, whatever you might call it, dot head, open parenthesis, close parenthesis, will print the first 5 rows of your data frame. And that's just a really easy way to get a look at it and see what's in there. Take a sniff, right? Head does the top of the data frame. There's another one called tail. That'll give you the bottom of the data frame. Ha. Head and tail, right? It's 5 by default, right? But if you were to pass a number into head as an input, you would override that default and you would tell the computer, no, I don't want 5. I just need 1. Or maybe I want 100, right? It's really up to you. So head is really useful. I would encourage you to run it on every data frame that you work on. Another one that I would encourage you to always run is .info. .info, like .describe, prints a little report card. And so we have here a report card about what's in our table. It's going to be really helpful. It tells you how many rows there are. It's 163 rows, right? So 163 helicopter accidents, right, in our data set. And then we have here a list of our columns, which were the same ones we previewed, but it's all spelled out so we can refer back to it later if we need to, right? And then like any good database or data frame, every column has a type, a data type, which tells the computer what type of things it can do with it. Like if you want to do math, right, you have to have numbers, and numbers, right, are integers is another term for number. And you can see here that this column, aircraft ID, this column, total fatalities, float is another term for numbers. That's a number with a decimal, right? You can see that Pandas has guessed the data type of a lot of our different columns, which is here on the right. And it's just not very human readable because the Pandas people have done a bad job. But basically, it's telling you that the computer has guessed that these are integer fields, which are numbers without decimals. These are floating fields, which are numbers with decimals. And so these columns could do math. They could do .sum. They could do .min, .max, right? The other columns Pandas says are objects. This is another poorly named thing, but objects just means it's characters or strings, it's words, right? Like the name of the helicopter, right? Or the name of the state where something is based. And words can't do math, right? And that's because, and the data type of the computer kind of regulates that. And so it's very important to make sure that your columns have the data types that you expect or that you want. A really nice thing about pandas is it guesses them for you, and it's almost always right, which is less work for you, right? You're really just reviewing the computer's work, but sometimes it's wrong and you need to override that. And there's ways to do that with read CSV that we won't cover here. Was there a question? No. Okay. So that is the introduction to the data frame, right? And we know from looking at it, we've made our first conclusion, our first finding. There were 163 fatal accidents, right? And I know that because that's how many records there are in the table. Analysis. Now, to work with your data frame, you often need to access your columns, right? So there's all these different columns in the data frame. How do you get your hands on them, right? And we saw here in the info, it printed out their names right there, right? And there's this one we've seen a couple times, LA Times make and model. That's what kind of helicopter it was after Ben has cleaned it up and fixed the government's data, right? So that's the column that will have the name of the helicopter in each accident. And because its name is LA Times makes and model, if you do accident list dot followed by any of your column names, it's going to spit them out, right? So there's that column, LA Times make and model, spit out as, guess what? A series, right? And if I were to go up here and I were to take state instead, and I were just to paste state over it and run it again, there's all the states, right? And so any column that is in your data frame is accessible via the dot, which is called dot notation. And they're there. Now, if your column name has spaces in it, which is pretty common, the dot won't work because the computer won't know how to read the code. It'll think that you're writing two different things and it'll throw an error like that. But don't worry, there's a way around it. If instead you do a flat bracket, quote, flat bracket like that, the exact same thing happens. And if your column had a space in it, it would work fine, right? I like to use the dot because it's just easier to read. It's less code. That's why I often give my headers underscores rather than spaces. But that's really just a matter of personal preference. It's not right or wrong. It's just what you like and don't like. Some people don't want to deal with having to do it two different ways, and so they always do it with the flat bracket, which is also fine, you know. Now, that series has its own, dot tab where we can see the many, many things we can do with it. And because this column is not an integer or a float, it's a string or object column, we can't do min and max because it's not math. They're not numbers, they're words, they're strings, right? But they have their own set of very interesting dot things that numbers don't have. One that's super helpful and we use all the time is called value underscore counts. So if you do the name of your data frame, a dot, the name of your string column, a dot, and then this fun function value counts, open paren, close paren, and hit play, boom, you get printed out a group and count on that column, a frequency table, or what Excel calls a pivot table, instantly. Wasn't that easy? And we see here that of our, what was the total again? Of our 163 helicopter accidents, 38 were the Robinson R44, right? 30 were the Bell 206. We have an accident ranking just like that, right? So just with that one little line of code, we've answered an interesting question. Which helicopter make and model had the most helicopter accidents? Congratulations. Right? Now you might see this series. This doesn't look like a data frame. It doesn't have like the nice clean column headers and rows and things. And that's because this is technically a series that has some numbers annotated on it in Pandas world. If you want to tidy this up and make it look like a data frame, a little more legible, there's this weird Pandas function that you'll have to use from time to time to do that called reset index. And what that really does is it takes the thing that you have and it converts it into a data frame. Why is it called reset index? I don't know. It's a bad decision. It's what the Pandas nerds did. And one thing about working with open source software is you're just kind of stuck oftentimes with how things were designed by the people who designed it. I mean, it is free after all. Who are we to complain? And so I think just as a beginner, it's good to just adapt, learn the quirks, live with them, right? So I hit play there. You can see it's now a nice legible data frame. If you get more advanced at Python and these things irritate you, it's all open source. Everything's on GitHub. You can go and suggest a change to the people who run it, and maybe they'll listen. I've tried on this one. They didn't listen. All right. So now we're going to do a little bit of an exercise together using only techniques we've learned here in class, nothing that hasn't been covered. And we're going to answer some journalistic questions in the cells below. It's going to be fun. It's going to be a little challenging. And then once we finish that, I think we might take a short break. Okay? Just to give everybody a minute and to give me a chance to get some water. All right. So here we go. I'm going to need some help from the crowd, guys. Here's the questions from your annoying editor, right? Okay, so I know how many accidents there were, right? Hey, there were 163 accidents. But how many people died? Because more than one person can die in a helicopter crash, right? How, using only the data we have and only techniques we've learned so far, could we answer the question of what was the total number of fatalities in the 163 accidents? It's going to require a little creativity, a little stretch. Anybody have a thought? Even if you don't know how to write the code, you have an idea of how we might calculate it from the data?
Well, we have to sum the total fatalities column.
You got it. That's exactly right. I went over it really quickly, so I'd forgive you if you missed it, but there was a total fatalities column that for each accident, like if I look at it here, had how many people died in that accident. Where is it? Hold on. My Zoom toolbar is getting in the way. Here. So one person died in this one, 2 people died in this one, 3 people died in this one. So if we sum this whole column, we'll know the total number of fatalities. You're exactly right. You have an idea about how we might write that code? Only things we've done so far.
Maybe value sum.
Yeah, we're going to use the sum. We're going to use the sum first, but we have to access our column, right? So we know our data. Okay. What's the name of our data frame? Do you remember?
Accident list.
Accident list. So if I type accident underscore list, like if I just run that cell, it just prints it out, right? Now you told me that we know the column that we want to deal with, right? It's total fatalities. So if I do dot, and now if I do total fatalities, like that, now if I just hit play there it's just spitting out the numbers as a series, right? Which is what we see here in the spreadsheet, right? So now we've accessed our series. Now what do we do next to get the sum? Do you remember?
Dot sum.
Dot sum, I know. Exactly. Boom. Dot sum, hit it. There's the answer. 336 people died, right? And so that's where we used the exact same technique that we used with our list of 2, 4, 6, and 8. We used on this data frames column, and no different code, but we got an answer to a pretty interesting journalistic question along the way. Very good. Okay, so the next question I have is, which helicopter maker had the most accidents, right? So we did the helicopter make and model with the most accidents. How would we get the maker, the company? And how would we know which one had the most? So let's look at our columns again. We had this LA Times make and model column, right, which we used before. But look, there's another column called LA Times make, right? And that has not the maker and the model. It has just the maker, right? So these are the Bell Helicopter Company. This is Airbus. This is Robinson. So remember, we can access our columns by typing in our data frame name, accident underscore list dot, followed by the column name. So dot LA Times make. There it is. And just as we did before, we can get a frequency or a group and count of the values with the value underscore counts method. So LA Times make value counts. Boom. We see Robinson has had 58. Bell has had 43. And just to quickly review, that's the exact same thing we did here with make and model. right? And the only thing that's different in the code is it's a different column, right? And so by using the exact same technique with a different column name substituted in the middle, we get the answer to a different question, right? But the exact same code, really. The sort of mix and match of your data and the techniques is really a big part of how this works. Okay, so we can do the same thing for the total number of helicopter accidents by year. Can somebody tell me what to type to get that calculation? You could look at the info report above or preview the data table would probably help. Don't make me call on you. Somebody.
Let me try. Can we use this value count method again
Yes.
by the column name of a year?
Yeah, so just tell me what to type and I'll try it.
Okay, and first we need the name of the list, accident underscore list, and dot year, and then dot value count, right?
That's exactly right. You got it, man. So there we have a really, you'll notice that it's not in chronological order, right? It's ranked by which years had the most, right? But we see that the year 2008 had the most accidents with 22, right? And we also here kind of get a look at the range of values in this column. This gets to what Ryan was talking about earlier, exploring your data. This is where value counts can be really useful to just quickly get a sense of like, in this column, what the heck is even in there, right? You know what I mean? What options are there? Particularly when there's like categorical codes or something like that, like the maker is an example, you know, it's nice to just kind of get a look at it. And so there's another one. All right. So if I wanted to do that now, for which state had the most helicopter accidents, what would I type? Yoshido, I bet you know the answer. You want to tell me what to type?
Maybe we can employ max.
What's
No.
I don't think it will, because max will only run on number columns. It might give us, what will it do? Yeah, so it says, look at this crazy long error. Oh my God, I hate computers. I quit, right? You can see at the very end, oftentimes the clues on your errors are at the very, very bottom of this traceback, which is frustrating, but that's how they do it. And we can see here, it's saying there's a type error, which means the data type is like not happy. And it's saying, hey, I expected a float and you gave me a string, right? And so max isn't it.
So do we have to use the value counts again?
We use value counts again. You got it. I know I wasn't very creative with these challenges, guys, but there you go. You see it. California, America's most populous state, had the most, which is 16. So here's where a rate might be helpful too, right? But we see there it is, California #1. All right, so that gets us to the end of that section. We're now going to move on to more advanced things to do with your data frame, things like filtering it to get down to just records you're interested in, things like grouping it to group and count and calculate more interesting statistics than just frequency counts, things like merging it to other data sets and calculating new columns, which is going to be a lot of fun. It's probably about another hour worth of stuff for us to go through, maybe a little less than that. But I want to, just take this moment now to maybe take a break. We've been going, we're probably a little past the midpoint. You can look here at my scroll bar. You can see we're actually a little more like 75% maybe of the way there, but it's been a lot. And so I just want to give everybody a chance to go to the restroom if they need to, or refill their coffee cup. And we can meet back here, let's say at 11:32, just to pick a weird number. At 11:32, we will resume and be right back. In the meantime, I'm just going to hang out here. And so if you have any questions really about anything, feel free to speak up. All right. So 11:32, I'll see you guys. Ryan, how we doing?
Feeling good.
Yeah.
There's a there's a good question from Cooper in chat. I don't know if we want to come back and talk about how you might explore something like that, or
yeah, I haven't seen it. Let me call. I kind of lost my Zoom toolbar here. Would you mind would you mind reading the question?
Yeah, what's going on in Arizona?
What's going on in Arizona? Yeah, exactly. That's what's kind of fun about, just listening to the statistics, right? Which is why I often think of it's, to me, there's a sort of spiritual aspect to that sometimes, but I'll restrain myself. Yeah, what is going on in Arizona? We'll explore that when we get into filtering. You know what I mean? We might be able to dig into the records. Like, I often approach it exactly like you are here. It's like I ask one question of the data, I get an answer back, and then I have a follow-up question, right? And so then I write another piece of code that helps me with the follow-up question. In this case, I might want to say, what's going on with Arizona? Let's look at the Arizona records, right? So maybe in our next filter section, we'll filter down to the records in Arizona to try to answer that. Because I'm paranoid. I don't know about you. I'd be like, Arizona seems like the rate's kind of high. Maybe there's some duplicates in there. Ooh, you know what I mean? Maybe Ben screwed it up, and like the one way to prove that is to actually look at the records, and so I don't know. I think, just having written this story, speaking from all I learned in my reporting, I would just generally say there's certain parts of America where helicopters are more common than others. You know what I mean? They're more commonly used as working helicopters in some places than others. But then I think there's also places where they're more popular recreationally, and California is definitely a place where helicopters are popular. In general, the West is a place where helicopters are popular, wide open spaces and all of that. But I don't. Mm-hmm.
I was just going to say, I think this is a really good example of, kind of like you said, listening to the data, like letting it tell you where to look for interesting stories. Because I think the subtext here is, yeah, California, Texas, those are like heavily popular. Those are like some of the most populated states there are. You probably would expect to see numbers be high there. And then like Arizona, maybe just kind of your gut sense is that might be an outlier. Like, to me, this is a good example of like, I found something interesting in the data, and like my next step is probably picking up the phone. Like, who could I call to ask, like, why is Arizona feel like an outlier here? So a cool example, good question from Cooper, like example of how to listen to the data and find like interesting things that might turn into stories.
Totally. That's it right there. That's it. Picking up the phone's a great way to go. A lot of phone calls on this story, man. To clean up that make and model column, I had to like learn so much about helicopters, because like the raw data from the NTSB had like every odd variation of every helicopter model. Like there, you call it the 106 Bell or whatever, but there's the 106A and the 106B, and there's all these like little variations, or they would spell it different, or the companies would change names over time. And so like there aren't that many helicopters, to be honest, like compared to planes or cars. They're pretty, small amount of variety, but I had to learn all of them to do the story. And that was me just in a spreadsheet, like that spreadsheet we saw, that's me in the database, just like going through, doing a values count on the raw ugly ones, seeing what they are, spitting that out into a spreadsheet, and then going through row by row and just being like, this is the R44, this is the R2, and just like categorizing it. And that like slow refinement of the data was the real work here.
Yeah, I know you have taught classes with political contributions data. Like, that's just such a great example of like data that has to have so much cleanup. When we were talking before the class, I pulled up some PDC stuff from here in Washington State and just looked at a local candidate, and there's like 18 different ways that my town is spelled in the data, because it's people entering stuff in a form, and like they don't care about getting it right. It's not necessarily a drop down, and there's different capitalizations, and like all that cleanup work is so much of then what lets you do stuff like this as quickly as you're able to
and we're glossing that over today in this presentation, that in reality just getting the data, basically understanding what it is and isn't, and then cleaning up its problems is like in most cases, and very much so in this case, are like 90% of the work. And then like 1% was doing the analysis. And then the last 9 were bulletproofing and making sure I didn't screw it up.
Yep.
You know? Yeah. Has anyone here flown in a Robinson helicopter? I'm always curious to know.
I've never been in a helicopter.
Neither have I. I do have my like newscopter fantasies, Ryan. I just got a drone license, and that's the closest I'm going to get, I think. But like my news fantasy for 2023 is that like I shoot some random local news event and like get it on the 10 o'clock news. You think I can do that?
We just got to get 2 drones that are big enough for you to put 1 foot on each, and then you're off. All right, I'm going to mute. We're at 11.
All right, we're at our restart time. Thank you for your patience, everybody. We're gonna now pick it back up, and we're gonna follow this through all the way to the end. All right. So our next step is filtering the data set. How do I take my table and how do I narrow it down to just the records I'm more interested in or that I want to analyze and look at? And Pandas has its own technique for doing this, which is it's called indexing or filtering that we're going to cover next. This is if you've ever done database software like SQL. This is really very similar, right? To the where statement in SQL. You have to make what's called an expression that's a test. And that test is then applied to every row in the data frame. And things that are true are kept after the filter, and things that are false are let go, right? And the result is that you just keep all the things that are kept, and that's the filter, right? And every expression has sort of the column or the series that you're going to evaluate, the test that you're going to run against it. Does it equal this? Is it greater than this or less than this? There's these different kinds of tests. And then there's the value you're going to test it against. And so a really common filter on a string field is I want to filter down the data frame to only the records where a certain column equals a certain value, right? And that's the example we're going to look at here. The example I wrote is for the state of Iowa, but because Cooper had this great question about Arizona, I'm going to change it to Arizona, right? And so we see I've created a variable. It equals AZ or Arizona. I'm going to run it. And now that's saved right there, right? That's easy. That's the easy part. That's just saving the variable. My state equals Arizona, right? Now here in the next cell is the hard part. This is how you actually do a filter in Pandas. You start off by naming the data frame, right? That's the data frame I want to filter. And then you do these flat bracket. The flat bracket is saying, I'm about to do some indexing. I'm about to do some filtering, right? That's how you tell that to the data frame. And then inside of the flat bracket is that expression I was talking about. And it's a little overwhelming at first, but if you just stop and read it slowly, you'll get it pretty quick, which is you have your first thing, which is the column that you want to evaluate. So you have to repeat the name of the data frame to access the column, right? So the column is state, right? So I have to do data frame dot state to get the column. I know it's dumb. You have to repeat it. That's just how Pandas works. I'm sorry, right? Second is the operator that you want to run. In this case, you want to test whether something equals something else. And the way you do that in Python is 2 equal signs in a row. That's because 1 equal sign is used to assign variables. So they can't use it here. The computer's strict. It's dumb. Expressions can only do one thing, right? So 1 equal sign is for assignment. 2 equal signs is for evaluation of an operator. Is one thing equal to the next thing, right? So our thing we're testing is the state column. And we're saying, is it equal to the variable state? Is it Arizona, right? So if I run that, boom, we've got our narrowed list that now is only the records in the state of Arizona, right? If I look at the state column, it's AZ, 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 right? And if I were to change that back to Iowa, where I grew up, and I were to run those 2 cells again, we'd see the list got a lot shorter, right? It only has 3 now, and it's IA, IA, IA. Makes sense? Pick another state, run it for yourself. I'll go back to AZ, gonna run it again. All right. Now to save that for use later, of course, you can save the result of your filter to a variable, right? And so if I named it, I was going to call it my accidents, but I'm going to call it AZ accidents. I'm going to change the name of that variable. I'm riffing, I'm off-roading, right? And I'm going to say AZ accidents equals the result of the filter. And now that is now a new data frame, right? With fewer records. And I could take a look at it using those same things we did before, which are head and info. Remember those guys? There they are. And we can now see when we look at the row count in the info report, there's only 14 rows, right? And that 14 rows matches what we got with our value counts up here, right? Because we filtered down to see just those 14. Now you could write that out to a spreadsheet and you could look at it in Excel if you wanted to study it, like look for problems, like I was saying. You could just sniff around here, but you've got something you can kind of play with now. That's filtering. There's other expressions, greater than, less than, which are often useful when you're evaluating number columns, right? I only want campaign contributions greater than $1,000 or something, right? Would just be like amount greater than 1,000, right? If I had a column called amount, which I don't in this case, but you get my point. But we could say total fatalities greater than 1. So we can say we want all helicopter accidents where someone other than the pilot died, right? This might give us that if we think about it, right? Because anything has more than one fatality. Well, I guess the pilot could survive and the passenger could die, so that's not true. But like, if we wanted all helicopter crashes with more than one death, this is what would do it, right? And that's me struggling through it. I want to answer this question. How do I and then it helps you think about it. Well, I didn't ask the question right, and then I had to loop back. That's filtering. Any questions about filtering?
So I'm just going to throw out the fact that you renamed that variable as AZ accidents.
I off-roaded.
Yep. No, but I just want to throw out that means that you still have access to that original, like the original filter also. Like, because something that I do to myself all the time is overwrite a variable that I was going to use again. And like that, my debugging process, often I run into things that I was just really dumb and got moving too fast. And and I just reused a variable name, a few different places in my code. And all of a sudden I'm ending up with different results than I'm expecting. And so renaming variables like AZ accidents like that is just a really helpful way. Like it may feel like, I'm getting cluttered, I got too many variables. Your computer doesn't care. And it's just a really nice way to make sure that I'm not accidentally overriding something that I might want to use and rely on later on.
That's totally true. It's totally true. Yes. And that's where, especially if I no longer need a variable, I like to delete the cell too. You know what I mean? Just to like get it out of there so I'm not accidentally using it. It's pretty easy, especially when you're doodling and you start to kind of get a little confused about what's where. It's normal, happens to everybody. It's part of the process. That's filtering. All right, we're going to move on to grouping. So grouping is when you take a column and you reduce it to like the number of unique values in it to groups, you know what I mean, into items, and then you do something with those groups. We already did this with value counts, right? In value counts, we were able to take our make and model column, and with that nice shortcut, we were able to group up how many there are, right? And that's because value counts is designed to be a shortcut, right? But let's say you want to do something that's a little more custom or isn't just counting frequency, but maybe is calculating statistics, right? To do that, you have to write your own group functions that have a little more going on. And that is just another dot method that's hooked onto every data frame. Every data frame has dot group by right there available. And you could pass into the parenthesis the name of the column you want to group. And so LA times make and model is what we did to count accidents by model, right? And so I'm going to group on that, which does nothing. It's just grouped it, but you haven't given it an aggregation function, something to actually do with each group, right? So to start, it just spits out, here's groups. It doesn't do anything yet. It's expecting you to chain something else on the end, which is a whole other set of dot functions. So if I do dot tab, again for autocomplete, it's not working for some reason. Okay. There's a whole bunch of them there. So dot size is the equivalent of value counts. So if you do a group and you do dot size, it's actually the same thing as value counts. It doesn't rank it because, but value counts is kind of a shortcut for basically this, right? Which is just count the frequency of items, the number, right? But let's say we want to do something more statistical, like we want to sum the number of fatalities per model. So I know the R44 had the most accidents with 38 accidents, but did it have the most deaths, right? To do that, we would need to do something we did earlier, which is sum the fatalities. But we don't just want to sum the whole set. We want to do a different sum for each one of these groups, right? And so that's just as simple as chaining onto the end a technique that we already used elsewhere, right? Which is to dot the name of the column followed by dot and the name of the mathematical function, which was sum. So it's just the accident list dot group by dot column name dot sum. And we get back, boom, the total number of fatalities for each make and model. And we see that the Robinson R44 had 38 fatal accidents for a total of 71 fatalities, right? And we see here that the Airbus actually had more fatalities. That's interesting. It's a bigger helicopter, guys, right? Mm-hmm. Now, that same thing gets spit out as this ugly series. Again, reset index is our friend. Just tacking that at the end can give you a nice data frame, right? So I've grouped the size, which is just the count for each one, and I've reset the index. And so that's now created a data frame that has each of our models, right? Oops. And the frequency count. But we can see that there's kind of a gnarly thing about pandas that it names that size column 0, which is just a dumb thing about pandas. So we're going to want to clean that up in a minute. Because if we think about our ultimate goal of calculating the accident rate, the number of accidents per make and model is going to be one of our inputs to calculating that rate, right? So we want to kind of polish up this table that's like our sort of finished finding about the total number of make and model for each. And so what I'm going to do here is just try to turn this like rough cut into like a finished data frame that's like the result of this stage of the analysis. And so I've got my group by, I've got my size, I've got my resize index. This is basically what I'm going to want to keep to take over to the survey data. I take that same code, I now save it to a new data frame, which I call accident counts, right? So now accident counts is what we see right here, but it's got that ugly column name, right? 0, So I want to rename that something a little more readable for later. And you can do that with a function called rename. So every data frame has a function called rename. It expects you to give it a keyword argument, which we haven't done yet, but these are basically options that you pass into functions that have names. And you can do them in whatever order you want, which is kind of nice. And most of them you never even need to know about. They're really only there when you want to override something. But when you want to rename a column in pandas, there's a couple ways to do it. And this is one of them, is you do the rename function on the data frame. You say the column's input is equal to a dictionary, which is we haven't seen yet either, which is a way Python sort of pairs together two different values. There's a key and then there's a value, and those two things are linked, and you can have a lot of them in a dictionary, And so here 0, which is the name of the column that already exists, I want to rename 0. So I'm saying, hey, 0, I want to rename you to accidents. And then in place is a pandas function that's in many, many, many of the pandas functions. You're going to see it all over the place. And it basically says, make this edit to the data frame in place so that we don't have to rename or reassign the variable. It can be dangerous, but I just wanted to show it to you because it's very common in pandas, is to say, I want you to do this operation and do it in place so that the edit to the data frame is saved immediately, right? So if I run that, and then I run my friend head again, you can see that column has now been renamed accidents. It's no longer named 0, right? And accident counts is kind of our finished analysis of the total number of accidents per make and model that we now want to take to our survey data, which has how many hours in the air each helicopter spent, to then adjust and normalize to calculate our rate. Any questions about group by? You can group by more than one column, which is done by just passing a list into the group by function, like so. And then you could give it a second column here, right? Very common. Okay, Now we're going to move on to another fundamental operation on databases, which is merging. Merging is where you take two different tables and you link them together using a common column. This is a great example of where getting into computer programming can be really valuable, because while you can do this in spreadsheet software like Excel or Google Sheets, it's not that easy. It's kind of a hassle, right? This is where coding can really help. And a lot of larger databases are often intentionally structured to have many tables, right? Now, in this case, we have two tables that we're bringing. We have, on the one hand, the make and model and the accident counts, which we've just generated with our group by. And then we have on the other, the FAA survey, which I've tidied up and prepared for class based on a Freedom of Information Act request and a lot of documents I got back from the FAA. But we can see here that this also has a column called LA Times make and model and total hours. And so for us to calculate our rate, we need to merge or join these two tables together so that one number can be divided into the other, right? And that's what we're going to do in this next section. We're going to read in FAA survey as a new variable using our friend from earlier, read CSV. So read CSV, which we used to read in the accidents table, can be used to read in the survey table, right? And only difference is just the file or name right there. So same thing all over again, just a different file, which is the name of the file here in the system. I'm going to hit that and play. And now, if I were to run survey.info, which is below, we can see here's the info report on that, which is there's 12 rows, there's 2 columns. One is a string or object, the other is an integer. And accident counts, which we created before, very similar, also has 12 rows, right? Has make and model and accidents. And what we want to do is we want to merge these two together, or what in other tools is called join them, using their common column, which is make and model. It's always really good to look careful at your tables before you join, so you know which columns need to match. You know how many rows are in each one. It's often common for there to be more rows in one table than the other, and you have to work out what you want to do with the ones that don't match, right? But in this case, we don't have that issue. I took care of it ahead of time. But you can think that through by just looking at it there. So to do the merge, there's another one of pandas tool belt functions, .merge, right? So PD, which is pandas, right? .merge. And then we do our parenthesis because we're calling a function. Now, merge can take multiple inputs because it's a little more complicated. It wants 2 data frames to put together, separated by commas. So our first data frame, which is often called the left table in a join, is accident counts. And our second data frame, which we just imported right here, right, is called survey, is our second table. That's our right data frame, is what it's known. And then those two things need to be merged. And you can give the instructions to merge on which column to use to join the tables with the on argument. So on equals, and then in quotes, the name of the column, which we see right here, all right? And then I'm going to save the result of that to a variable merged list. Boom. It's also important to inspect your table after every merge to make sure rows didn't get dropped due to joins being missed or anything unexpected happened. And so I will usually run ahead and info immediately afterwards just to make sure things are what I expect. So we see here, we now have for the make and model, we have both the accident count and the total hours sitting side by side in a new connected table, right? And we can see that there are 12 rows in it, which is exactly what I would expect. Commonly, if there was an error or something you didn't want, this number would be less than 12 or more than 12, which might mean the join that some of the values appeared more than once or didn't appear on one side of the join or the other. That's it. That's merging. Any questions about that? No? Okay, we're going to move on to computing a new column. Remember, our mission is to calculate a rate, right? And so that means to adjust the number of accidents for the number of hours that each helicopter was in the air to try to make it fair to compare helicopters that were flown more than others, right? Now, that's just generally a good practice when it comes to comparing things of different sizes or different frequencies, right? But in this case, it also was to vet a claim being made by John Robinson, CEO of the Robinson Helicopter Company, who told me and Kim Christensen that, yeah, we have the most accidents in our helicopters, but we also have the most pilots in the air, dude. So your story's crap. Don't even try running that. I got lawyers, that kind of thing. Those weren't exact quotes, FYI, but that was the kind of vibe of it. He definitely explicitly said that the reason they have more accidents is they have more helicopters in the air, which is true. But to evaluate whether his claim was true, we could calculate a rate, right? And it wasn't just that I invented this idea of coming up with the rate. One, he had made a claim and I was checking it, right? And two, there actually previously had been an FAA study done in the 1990s, about 20 years before, that used this exact same methodology. The FAA study took the accident numbers, they took the flight hours from this exact same survey, and they calculated rates. So I was able to basically replicate a method that the government itself had already endorsed as a safety check, which is really great way to approach designing a data story, because it takes a little bit of the it takes away the factor of like you're just in the LA Times or your outlet is just kind of inventing a standard it's holding people to, right? In this case, this was a standard that the government itself had established and had used in formal safety tests in the past, though it had been a long time. And two, the CEO of the helicopter company had made a claim along these same lines. And so for that reason, the analysis was sort of support, had more contextual support that maybe is boring. I should stop talking about. But FYI, I think that type of design is really important to crafting effective investigative stories. All right. So how do we actually calculate it, which is probably more what you want to know. You just get back to a lot of the basics that we've already covered so far, just returning in a slightly different way, right? So we know that we have this new table that has these three columns: LA Times make and model, accidents, and total hours. And calculating a rate is really as simple as dividing the accidents into the hours, right? And we know we can access the columns as series, right? So it's calculating the rate for each column, each row is as simple as taking the accident series and the hours series and putting the math operator in between the two. It's that easy, right? And then you run that cell and you can see there, boom, is a series that's calculated the rate for every row in our table, all 12 rows, that quick, right? And this same thing can be done for 1 million rows, right? Because pandas is cool. But we want to save that as a new column on our data frame. We want to calculate a new column and stick it on there at the end and save it in the same way that you might calculate a column in Excel with a formula, right? And the way you do that is just with the same assignment trick that we had before. When you add a new column in pandas, it's good practice to use this flat bracket approach, right? So that we showed earlier. So if you do your data frame, a flat bracket, quote, and whatever you want to name it, this will create a new column on your data frame that will be the result of whatever is on the other side of the equal sign. And so here I'm taking that exact same math operation. I've just pasted it down here and I'm saving it to a new column that I'm going to call per hour, right? So that's accidents per hour in the air, flight hour. And if I run that, nothing comes out because it's been saved. And now if I do head, boom, per hour, there it is, right? We've now calculated a new column, tacked it straight on the end. Now you can notice that this has this stuff at the end. Ryan, do you know what that is? E equals 07.
I can't tell you what the number is, but it looks like scientific notation to me.
Pop quiz, Ryan. Yeah, exactly. It is scientific notation, which is just a fancy way of taking zeros off the front end of a number and kind of moving the first significant value to the front, right? Is kind of what that does. It's not very easy for us humans to read unless we're super nerdy, especially me. I should speak for myself. It's not easy for me to read. Maybe you guys have an easy time with it. And so one common way of dealing with this issue when calculating rates, you see this with homicides, you see this with all kinds of rare events, is to just take it times a number that starts with 10 and ends with zeros, right? Depending on what's kind of appropriate. And you see this all the time with per capita statistics about things per million people or 100,000 people or 10,000 people, calculating rates really commonly to do this. And it has no effect on the actual number. It's just a way of framing it that makes it a little easier for our human brains to parse, right? And so we want to do per 100,000 hours is how we decided to do it, but there's really no difference between that and 10,000 or a million. It's just kind of what works for the data and it makes sense for how you're going to frame it. And that is as simple as what you see here. So we have the exact same mathematical operation that created the per hours column. I've put parentheses around it just so that those will run together first, just like in elementary school math class, right? And then after the parenthesis, I've done the asterisk, which is multiplication. And I've just put the number 100,000 right there. One underrated Python thing is you can put an underscore there to make the number more readable, and it still works. I like secretly love that trick. And so it's just going to take the result of it times 100,000. And I'm going to save it to a different column, which I'm calling per 100K hours. Then I run that. I should put a head in here, which I didn't do. So I'm going to add a new cell, do a head. And we can now see that there is this new column, right? And so we can say for the Augusta 109 make and model, there were 2 accidents in 360,000 hours, which works out to a half an accident per 100,000 hours, which still isn't that readable. You know what I mean? Honestly, like per million hours might be more readable for the average person, maybe. But I kind of felt that because a lot of these didn't have 1 million hours, it wouldn't be appropriate to do that adjustment, is kind of what I felt, because it would be sort of inflating it, not inflating it, but it would, it would be a step of the scale a little further than what the data is at, But again, all that is subjective. That work for everybody? Any questions about calculating new columns or computing new columns? I never know what to call this. Is computing the right word, Ryan? What do you call this when you do this?
Yeah, I think that's a fair term to use.
Mm-hmm.
You're running a computation and saving the results into a column.
There you go. So congratulations, everyone. You are now computational. You can put that on your resume. Okay, now we're getting to our last section, believe it or not, right? And this is about sorting. This is another really common practice, in spreadsheets or with data, is to use one of your columns and to just resort the data frame according to that column in one direction or the other. And in our case, our goal is to calculate which helicopter make and model has the highest accident rate, right? And our per 100K hours column is going to be a way to approach that. And all it is taking your data frame, which again is merged list, the dot operator that we've been using all day, and then this new function we haven't used before, which has a really verbose and annoying name. It is sort underscore values. I've always thought, why not just dot sort? Well, I don't know. They just decided. Some nerd years ago decided to write it long, and now we're all stuck with it. So it's dot sort underscore values, and then it needs the input, what column to sort by, right? Again, you put that in quotes. And if I run that, we'll see there's the result, right? So here's our table that has been resorted according to this column. And if we look at it, it's getting higher as we go down. And that's because by default, things are sorted in ascending order, which is from lowest to highest when it's a number, or from A to Z when it's a object or string, right? And so there's just another technique for reversing this to sort in descending order, which I'd like to do here. This is also very verbose, which I find annoying, but you have to do comma ascending, which is the option that was defined by the pandas developer, equals. And we haven't seen this yet, but in Python, there are these things called Boolean operators, that whether something is true or false. It's a data type, right? Something can be true or false or not exist, which is called null, or none in Python is what it's actually called. And so if you say ascending equals false, which is a little bit of a brain bender, you're basically saying do it in descending order, right? It is ascending is false. And that will reverse the sort so that now the highest values come first. We've sorted by scandalous. That's what I call this in the newsroom, Ryan. Sort by scandalous, right? And we see that there, number one, A1 with a bullet, is the Robinson R-44 helicopter, which has had 38 accidents in 2.3 million hours, which comes out to 1.6 accidents per 100,000 hours. Number one of all make and model over a long period of time, contrary to what the CEO of the company says, and in line with estimates done in the 1990s, 20 years ago, showing there's been little improvement in the Robinson's performance in this metric, which is the subject of our story. And blah, blah, blah. You can read it. That's it. And so we have now, I guess, at almost exactly the 2-hour mark since we began, completed this tutorial. This is the first time that this has been taught with this data set and in this way. So I'm sure I screwed up all kinds of stuff. And my hope is now maybe we could have a brief conversation that can answer any questions that you all have. And also you can give me maybe some feedback and criticism about what I messed up. But before we do that, I guess I think I would ask Ryan to maybe stop the recording so that people could feel free to speak frankly without knowing they're going to end up on YouTube, you know?
Yep, you bet. I'm going to push stop.
Thanks, Ryan.